Good evening, sirs. Wow, it's nearly midnight. That's a bit of a weird timing. Okay, so we're going to make a zombie. I thought I'd show you the quick game before we start. Well, yeah, I'll say game. So we're going to make this zombie behaviour work. It's sort of random wander with a bit of pushing, but so these zombies are kind of milling around. So I wanted to do a kind of random wander zombie-ish kind of behaviour. They do respond to the fact that there's humans around, and they do try and eat them, as you can see by the debug lines. So we'll start with the basic zombie stuff. So let's just go through a bit of the theory before we get started. So what I'm saying is this is Ed, right? So Ed's a zombie, and what you generally do with a zombie is you have a random radius around him, or her in this case. Well, actually, well, okay, Ed's a him, but the zombie we're making is a her, called Jill. So you have this radius around Ed, and the idea is that he'll walk somewhere inside that radius randomly, choose a position, and go to it. But that's actually not the ideal case. What you actually want is this not just a sort of radius to wander around, because that would be a fixed distance. What you actually want is to have a range, and what I'm showing you here is that there's a range between a minimum size and a maximum size. So what we're going to do is we're going to essentially choose a distance between the minimum and maximum and make our zombie go to that position. So we'd make a random angle around them and just move them within a minimum and maximum distance. And the reason why I like the minimum maximum distance thing is that it gets too repetitive if you always use the same distance when you're moving. I've noticed that that's one of the big sort of telltale things when you're looking at different behaviours, is when you give simple distance every single time. So it's useful often to just do slightly random. I mean, this size doesn't have to be quite so big. It could literally be just big enough to sort of literally work exactly the same way, but giving it a minimum maximum distance is always usually a good thing. So the other thing is that we should be able to essentially, basically do a random in any of these directions. So that's the typical standard behavior, but I think we should do something a little bit better than that. So take Ed, think of his usual sort of distance circles, but then think, well, why don't we offset the center of that circle? So we'll allow some way of offsetting where the center of that circle is, and then we can generate a random position inside the range like we did before. But the thing that you should notice about this is that when we're doing this random generation, what we're essentially doing is driving the zombie, even though we're doing random positions, but driving them in an overall direction, because we've offset the center of the point where we're generating the radiuses for. So that offset value is actually quite useful if you want to have essentially zombies move in a direction while still being kind of random like zombies would do. So we'll build all of that functionality into our zombie code, because it's kind of useful to be able to have interesting looking behaviors like that. So let's start with the typical setup. What have we got to do? We've got to do new blueprint. We're going to need a character, so an AI character. Let's just what should we call it on character? Okay, so it's just based off character, not an AI character. I don't think it was an AI character. And we'll call this zombie Ed. You could call it what you like. We also need a AI controller. So we'll make another AI controller. Call it zombie Ed controller. We need the behavior tree, so if we go to, where is it? Miscellaneous behavior tree, zombie Ed BT, and we need, again, miscellaneous, a blackboard, zombie Ed BB. So that's the basic file thing we need to set up. We're using the character. We've done the controller, the blackboard. Yeah, I think that's all we need for now. We're going to use an existing animation and skeleton mesh thing. So let's just set that up to start off with. Actually, you can't see that on your screen, but I shall move over here. So we're essentially going to go to our components, mesh. We're going to use animation blueprint. Now what I've done is I've used the Mixamo animation. So if you go to your Unreal Engine launcher and you go to Marketplace, I think it's in Marketplace, or is it not now? Okay. In my case, I've already downloaded it, but you should be able to get it from the Marketplace, the Mixamo animation pack, and that gives you a number of characters, and you can just add that to your project. So if you do that, what you should have is a number of animation blueprints, and obviously the skeleton mesh for those, and it's Jill that we're after. So in terms of the mesh itself, we just want Jill, and we probably want to put her, it's just, she's a bit big. She's a big old girl, isn't she? Oh dear. So we probably want to just scale her down. Well, let's not scale her down for now. Let's just why is that? There we go. For some reason it wasn't bringing up the rotator. So we want her to be inside the capsule. So if you press W, E and R, you get the various things for setting that up. If I can actually see it properly, I'll just expand that a little bit. Move her feet down. What you could do is just use the default. Yeah, looks near enough. We can always fix that up later. You could use the default character for that and just take a copy of it, I suppose. May have to do that later on. So the other thing is that what we probably should do is set a maximum walk speed for them. So if the default is 600, I think let's say 200 as a sort of zombie-like speed. And there's a couple of other things you need to think about. One is whether you use avoidance. And if you go to my playlists, I've done an AI movement playlist that you might want to have a quick look at. It's got the paper for where this came from. RVO avoidance is reciprocal velocity obstacles, and that's the sort of default method used by Unreal Engine, but it's not particularly great. Let's just set this to default value. It's not particularly convincing in terms of humanoid walking, but anyway, that's neither here nor there. Let's not worry about that. So that's our character setup. Easy enough. let's go back to the just copy that onto my other monitor. What else do we need to do? Well, we need to set the blackboard and the behavior tree together. Let's just make sure. Oh, again, spawn onto the other monitor. Yep. So we need to make sure our behavior tree is using our blackboard. Yeah, so we can do something in our behavior tree now. So let's just save that. So what we actually want is, we typically want, just make sure you remember to put a selector underneath the root node, because otherwise you get some really bad stuff going on. What we want is, well, let's think about it, right? We probably want some kind of wait, just to give the zombie a little bit of kind of the occasional stop. So let's say we wait for a second. And then the other thing is that we probably want a sequence. So what's our sequence going to do? It's going to, if we see a thing to eat, we're going to walk towards it and we're going to then attack it. So that's probably what we want to do in terms of like eat human. So we're going to need to fill in our kind of stuff first, but first we need a blackboard thing that says, okay, let's have a new key. It's an object. Let's call it target human. Yeah, why not? Or target object, I suppose. Make sure, again, like I said before, make sure that you switch the base class to actor in this, because otherwise things get quite funky in the behavior tree system. Are we using 4.4.3? That might be fixed in 4.5, I'm not sure. So blackboard, save that. So what we're saying is, if there's let's add a decorator for a blackboard. It says if the target human's set, then we can run this node. So let's call that something like so what we'll probably do is I'll move to, this is all getting far too easy, isn't it, really? So if we see a human, we move to them and then we do some damage to them. We've kind of done damage in some previous videos. So for now I'm just going to apply an existing task that I've already written. Now let's just have a quick look inside that task. So what we're saying here, there's two values. One is the value that we're going to apply in terms of how much damage we do to them, and the other is a blackboard key selector. So again, we can just add a variable, change it to a blackboard key selector, and call it whatever we like, but given that we've already got one, I'm just going to use the existing one. And that is a selector that shows up in our behavior tree to allow us to select essentially the thing that we're going to target. So let's just have a quick look at the logic for this. So when we receive the execution for this task, we check to see if we get from the blackboard an actor using the key to reference which actor it is. We're going to check that it's valid. If it isn't valid, we need to call finish execute. Basically we're saying if it's not a valid target, then just finish execute anyway. If you don't call these finish executes when you receive an event receive execute, your behavior tree will just sit there forever, which is why you kind of need to make sure that all of your paths are going to end up at a finish execute. So what we're going to say is, if it is valid, then we call the apply damage node, which is on the actor, that we returned from the blackboard, and we apply the damage value. We haven't filled in any of the other things, but we could have filled in the instigator as the thing that's actually doing that. But so that apply damage will pretty much apply damage to any actor, and because we've got an actor value from here, we can just call apply damage on it, and then we run into a finish execute to finish off. So that's a really simple task, and that task will essentially damage any actor type, and obviously the thing itself has to handle, when it's being damaged, it has to handle an event that gets received when the apply damage is done from this end. But essentially that task is quite a simple one, and it just makes it easier for us to set up our behavior tree. So damage, and we don't show property details, or let's call it eat them. And our target would be the human that we've seen, and let's say we do, I don't know, 25 damage to them. These values are kind of arbitrary, depends on how much health we've given them. Just a floating point number essentially. So what's going to happen is that this zombie's going to come in. If it sees a human, it's going to move towards it and eat it. And this is going to keep, essentially, looping. Because the human thing will always be set, so it will see human move to eat, see human move to eat. So maybe what we want to do is have a little bit of a wait after that, just so it's not immediately kind of killed. So let's just wait, and not 5 seconds, let's say 0.5, just to give the human sort of time to run away. So that's all right, but then we've still got a set of behaviors that we need. So that's this sort of, actually let's just go sequence in case we want to do something interesting with that, and we'll break the link to that and add that as a child of that sequence. So that'll be the idle sequence. I like to sort of organize my trees in terms of these kind of things. So that's the sort of see human sequence, and we probably want another sequence which we will call wonder. So what will the wonder do? Well, the wonder will take in, we'll have a target location, so probably we should start adding that value. New key, let's call it a vector, target location. It'll probably move to even this target location rather than the target human. So what we need to do is we need to choose what that target location is, and then maybe we want to sort of use one of the kind of decorators, something like the cooldown, just to make sure that it doesn't keep selecting the wonder one after the other. it gives the chance for it to idle and do something kind of animated. Maybe not for this particular session. Okay, so what else do we need to do? Well, we need to figure out how to do a move, and I've already done a task for that. So normally we'd go new task and give it so BT task blueprint base. We'd create a new task and rename it. In this case, I've named mine random compute choose random move. So I've called mine choose random move. So let's just have a quick look what we've got in there. So this is actually quite a complicated task. So I'll just talk you through the sort of idea of it first. So we get the execute event as we normally do. Now, the first thing I want to do is I want to get our remember there's the sort of offset value for where our random location is going to be centered. So we need to move our kind of radius a little bit. We might want to have some value in a vector that offsets where we are. So what I'm doing here is that I'm getting our current location and I'm adding to that the bias vector. I called it a bias vector, so that's like the offset from the center of our circle. If you remember our Ed guy, instead of randomly wandering around a circle around him, what we're saying is that circle normally would start at this location, but we can add a bias vector, a sort of movement vector, to say go in a specific direction. It'll still be random, and we're storing it in this center vector. So essentially that is the offset center, whereas would normally take just the actor location. So then we're going to compute a random float between 0 and 360, so 0 and 360 degrees, and set that in heading angle. It's just so that we can use it later on. And we're going to use that heading angle we just computed. So we're basically taking a random random float value and sticking that into a rotator called orient. So essentially something that will rotate around the yaw by our random value. We then take that orientation variable and we rotate a vector by that orientation and store that in the direction vector. So again, the direction vector is the direction our character is then going to move. Now that direction vector, if you see this, it's basically got a length of 1. So what we want to do is we want to scale that length up. And in this case, I'm using a random float between 200 and 800 as the scale of the sort of random movement circles. So remember I said that it's probably useful to have a minimum maximum rather than just one radius. And then I'm computing using those minimum maximum radiuses, radii even. I'm coming up with a random distance that I want the zombie to move. I'm taking the direction, which remember was like a unit length vector. I'm multiplying it by that distance, so the shamble distance. I'm then adding that new vector to the offset center of our position, and I'm storing that into a vector called the move target. So I'm using this blackboard key selector to say which vector in the blackboard I'm talking about. And then what I'm doing is I'm setting the bias move vector back to 0. So basically I compute, where do I compute the bias vector? Okay, so I expect a bias vector to be in here if it's Non-zero, it's basically adding an offset, and what I'm doing here is I'm setting it back to 0. So if it was set, I'm resetting it back to 0 as an offset, which means that normally you have to be supplying it with an offset vector each time you want it to move in a direction, so that you can do things like move it along a path or whatever. And the reason why I reset it is that I don't want to always apply the same kind of move direction necessarily. So I'm expecting that I would have another system set up to set this bias every frame, and this one just consumes it. Essentially, it says, right, okay, so I'm using the current value and then I'm resetting it to 0, so it won't have any effect if it's been reset. Essentially back here, this will have no effect at all if that resets happened previously. And then I'm just calling finish execute because I know that this whole stream of execution is going to work. So that's a pretty it's complicated in terms of variables and things, but actually when you look at the from the behavior tree standpoint, what we're saying is we're moving a target, and we're using, actually we haven't got the bias vector in the blackboard yet, so let's add a new vector, movement bias. So let's save that. So we've got the target location we're going to set, and we've got the sort of movement bias vector that we can supply, and usually that would just be 0, 0, 0 to mean don't bias it at all, and that would generate the circle around our player, our character as per normal. So that's not too bad. Let's just rename that to choose random move. So it's going to choose a random movement point. It's going to move towards it, and we probably want to think about how we're going to limit this kind of movement sequence, because what we essentially want is we want this movement sequence to take priority over this one, but eventually, or rather occasionally, allow this stream to happen. We want this to essentially subsume, to take over if any of these are already playing, so we'll probably want to abort lower priority. And you'll see that when you set an abort lower priority, you get these kind of blue colours on the nodes below it. That means that those will be stopped if this one becomes true. So I'm just going to take a quick break there, and when we come back, we'll flesh out this behavior tree a little bit more. So where were we? Yeah, okay, so we've got this behavior tree. What we're after doing next is, I guess, we need some way of setting this target value, right? So we've got a blackboard entry called target human. That's who we're going to try and eat. So if that becomes set in the behavior tree, this equals a run, which will move to them, apply damage to them, which is like we should probably do an animation here, but we're not going to do that right now. And then little wait state, we might want to take that out if it doesn't look quite right, but it gives us a chance to sort of make sure that we're doing these things. So what else do we need? Well, the other thing that we probably want to do is we want to look at, if we go to blueprints and open level blueprint, we want to spawn the characters, right? So here's how you do this a spawning thing. So what I've done is I've added an integer variable called zombie count, which is how many zombies you spawn. I've got an object in the scene which is, if I go back to here, I think I just did a target. Okay, so I've got a named target point. If you go to basic, get down the bottom, target point, it's just a thing in 3D space, which is all we need really. So I've got that target point and I've dragged it in here. So if you select it in the scene, you should be able to right click and add reference to. So basically when you select something in the scene, it usually adds this to the nodes, and I've just added one here. So what we're going to do is when the game starts playing, I'm going to do a for loop, and the for loop is going to basically loop around from index 0. It's going to loop around for zombie count times. So if I click on the zombie count, I've set it to 46 right now, and essentially it's going to call, in this case, spawn AI from class. So I've got a spawn AI from class node in the loop body, and what that spawn AI from class does is say what type of what classes it's going to use for the spawn object, what behavior tree it's going to instantiate for that class. So basically our zombie ed and zombie ed BT, and then it wants a location and an orientation. So what I'm doing here is making a random yaw, so basically making a random facing and shoving that into the rotation, and in here we're doing that random float direction thing again, making a rotation, applying it to the vector like we did for the wander essentially, and then zombie spawn radius as our sort of minimum's 100, zombie spawn radius is our maximum. We're doing a bunch of random floats and randomizing that position, and then shoving that out in a return vector, which then goes into the location. So basically spawning the zombies in a random place somewhere in a radius around the zombie spawn point, this zombie spawn point in level. So essentially a radius of 360 around this object, but I've just placed in the center of the world. Now there are other ways you could do that, but this one was kind of easy enough just to test it out, and if I simulate, it just spawns things kind of around there. So we've got the kind of random wander. One thing you'll notice is that the zombies tend to kind of they kind of slide sideways sometimes, and that's the problem with the velocity reciprocal velocity obstacle avoidance system that we switched on with that flag in the character. Also the zombies are a little bit small, probably scale that one up a bit. So what we need to do next is we need to set the target human thing, and the question about that is how do we want our zombies to know how to react? The big problem is that I'm just saving the level here while I'm talking. The big problem is that you don't necessarily want to have them doing a sight check on everything, because there's going to be quite a lot of them and it'll get quite slow if we do that. So one thing we probably should do on the zombie itself, I'll just drag this over here. While we're here, well, let's just scale a zombie up. Why is she so small? Yeah, okay, that probably needs to be a bit taller. Let's just scale her up a bit. A bit more. Oop. Okay. That's a bit too much. There we go. I like it. So one of the problems is that we want to remember we did in the guard tutorial, we can add a pawn sensing component, or a pawn noise emitter, and this is under the AI section. So we'd probably want to be able to emit a noise and have the zombie react to it. So we want a pawn sensing component on the zombie, But we don't want the zombie to only react to players, so we'll switch the only sense players thing off. We do want a sensing update. We could switch the sensing interval down to save us a little bit of that kind of time, but I think what we should do is we should have it so that the zombie only reacts to noise to start off with. Or well, let's see how that one goes for now. So let's just save and compile that. So the other thing is that we need something to actually generate noise. Now I've already got a student here, again another Mixamo character, and she's got a pawn noise emitter on, so she can essentially send noise events out into the world. And so what I've got is, in this character, let's not do it here, let's not do it in the student. So what we want is, we want the actual kind of so this is the handling for the damage for the student. Actually, let's have a quick look at that before we move on to how we're actually going to do that. So you'll be able to apply this event damage, event any damage, on any type of actor, and in this case we're doing it on the student, and we're getting that damage value, if you remember, from the zombie. Where's she gone? Of course it's from the zombie blackboard, that's why. So where's our zombie blackboard? There, behavior tree, sorry. We're doing the apply damage in here, right? So this task is essentially calling the apply damage function, and that gets routed to whichever object you're applying it to, obviously. And so we'll receive this event for the damage, and this is the damage amount. So the damage amount, you basically take the current health, subtract the damage amount from it, set the current health. If the health is less than 0, basically we're dead, right? Less than or equal to 0, we're dead. I used to print that value out if I want to, so I can do that. If the value is less than 0 is true, or less than or equal to 0 is true, then we destroy the actor. So basically, you know, if the zombie takes our health to 0, we're dead. Otherwise, it just it makes a noise, and here's the thing that's actually going to drive our zombie behavior. So there's two parts to what I'm doing here. One part is I'm letting a zombie apply damage to something, and when that zombie applies damage to something, in this case a student, I'm calling a make noise. Now this make noise, by the way, happens to work in 4.4.3. Now in 4.5 you have to add the event for the pawn noise emitter instead of just the pawn. So if you can't get this noise thing to work, if you can't get your zombies to react to noise, make sure that you're adding the event on the pawn noise emitter and not on the pawn itself. There's a slight difference. If you need to, what I would suggest you do is go to Window, go to Palette and switch that on, and then in here do just search for noise, and it'll show you all of the different it'll show you all of the different things that you can get for creating noise. So anyway, yeah, and the noise basically uses its own location as the center of the noise, and the idea is that the zombie, when we're actually making the zombie work, will hear the noise and do some logic to set the the target, right? So let's go to our zombie head again. So what we need to do really is need the zombie to react to our event. So there's a couple of things that we need to do. We need to react to begin overlap. Ooh, that's a bit small, isn't it? So we want our actor, our zombie actor, to react when it gets touched by another actor, but only if that other actor is something that the zombie should be able to aggro on. So what we probably want to do is we want to say if the actor has a tag, and let's just pardon me, let's just make a literal tag. So we make a literal name here, and I've used the tag kill me on the students. Oops. So we do an if statement here and say if the actor has a tag, then we want to get Blackboard, set Blackboard. Watch out for the context sensitivity here, because for some reason the context sensitivity sometimes filters out things, which is a bit of a nightmare. But so what we want to say is if the actor has the tag of kill me, then we should set its target and there's our key name, make name. So what is our key name for our behavior trees? So our key name is target human, right? So it's the name of this key. So let's go back to where are we? I've lost myself. Oh, there we go. Target human. So basically, if we get a touch and the thing that we're touched has a tag of kill me, then we set the target human value in our Blackboard with the value of the actor that hit me. Right, so that should react to an overlap. So the idea is that when you bump into a zombie, the zombie will react by setting you as a target, and once the one zombie gets bumped and essentially attacks, in this case I've called them students, but that's probably a bad name. Okay, we probably want to do get Blackboard. So what we're saying is the zombie itself will attack things that touch it if the thing that touched it is an actor and if it's got a tag of kill me. So in our student, what I've got is sorry, hold on, I'll just save all of that. In our student, I've added a tag. Why is that? I've added a tag here called kill me. So basically every actor has tags. You won't see that by default, so you have to click the show inherited values, but every actor has a tags array, which is an array of names. If you click on the array of names in the tags, it will be empty, and I just added one called kill me. So basically anything that you want to have the zombie aggro on, add that tag and it should do it. So the thing has to respond to taking damage requests, and obviously our student did, because that's where we're doing it here. So going back to the zombie, wrong one. So going back to the zombie, so we're handling, let's just make a comment block for that. Handle touching student and set it as our target. So that's one thing that the zombie needs to do. The zombie also needs to hear. Remember, it's got a component with pawn sensing. So we need to be able to, where is it, component? Pawn sensing. Let's just see if it's got, okay, so where did that go? Okay. On here, noise. No, it didn't. 1 second, I'm just going to cough. Sorry about that, I'm back. So, yeah, as I was saying, we need an event here. It's on the pawn sensing component. I just completely forgot about that. So we added on here noise event. What we're saying is the instigator in this case will be the thing that's sent the noise, and that is the thing that's taking damage, in this case the student. So the thing that takes damage does a make noise, and then we get an on here noise event in here. So all we need to do really is we need to we could do a check again to say, does this thing have the kill me actor has tag? So let's just check and make sure it's valid first. So it's a pawn, and that takes an object, of course. Well, it's just for now. Trust that it's going to be valid. So what we want to do is cast to actor. Oops, sorry, actor has tag. And make literal. And that is kill me. So basically the same thing as we did here. And then if that's true. See, now the thing is, if we're doing the same thing, maybe we could kind of wire these things together and just go through one set of logic. But for now, set value, sorry, there is a set value, and of course take context sensitive off. You set value as object, and again we need to get blackboard. So that's who we're going to set the value for. Key name again, make literal. And don't forget, this one is target human. So again, what we're saying is when we get a hear noise event and it's got an actor with a tag of kill me, then and if that's true, then we set the object, set the value of an object in a blackboard with the tag target human, and set that value to be our object. So essentially, if we hear something that's got the kill me tag on, then we shall set that as our target. So let's just add another comment here. Something like heard student take damage, aggro that student as our target. So basically the zombie, if it gets touched by a human, will do damage to it. That human will then make a noise which then other zombies will hear, and so that should theoretically give us some zombies that can aggro students. So if there's zombie hits a student, okay, so there's something strange going on a little bit there in that they don't seem to be getting a collision. So what I like to do is, if I'm not getting what I expect, I just put a print string in there to make sure that something's actually happening. So let's just, for debug purposes, add a print string node, and just call it whatever you like, really. So we should see some of these being printed out. Let's just simulate for now. So we're definitely not getting any collisions with the zombie, which is interesting. So let's go to our zombie, not a test zombie, our zombie, where are you? Zombie ed, there we go. So it could be actor begin overlap isn't the correct one. Maybe it's that. Maybe it's the fact that we're using the wrong type of overlap component. So let's just see if that literally just checking to make sure if this component overlap does end up being the correct one, you can just replace this node with this node and wire it up properly and we should be sorted. So again, go to it, simulate it, wait until a student actually comes into contact with a zombie. Okay. So we're getting zombie overlap events occasionally. That's kind of interesting. Now here's the question, right? It could be, if you remember our zombie, we did have in our character movement component, sorry, let's go to components view, we did have in our character movement component this whole where are we, avoidance thing. It might be that the avoidance is just disabling our character actually hitting the student properly. So let's see if that makes any difference. So what you'll see now is that you'll see a lot more collisions, direct collisions. So we're getting some zombie overlaps. But not a huge amount. Certainly not as many as there are collisions with the character. So let's have a think through. I mean, something's happening over here. We're definitely getting some behaviour, but that just looks like there's kind of collision problems, right? So it's probably not the collision avoidance thing. In which case, let's go back to our... Where's our zombie again? I keep losing him. Let's switch our avoidance back on, because I don't think it's that. Maybe we can sort of tweak this value. So the question is, what is it that's causing our overlap not to happen so often? So we are getting this event firing occasionally. We're not getting any of these events firing as far as I can tell, because we haven't had a zombie hit an actor thing yet. So let's do this for a start. So we're essentially replacing the actor begin overlap with component begin overlap. Let's see if that gives us any more convincing behaviour. So I've turned the RVO back on just so we get a little bit of avoidance. Okay, it's definitely not quite right, is it? So how is the sensing not actually working? Actually, that's something I should probably do. Let's go back to our test zombie ed. And let's... Oh, actually, we're not getting any of those prints again, are we? So maybe even component begin overlap's not quite the right one, because we're not getting any of these actor things. Zombie hit an actor printouts. So what else could be? Well, it could be that we've got this name wrong, but I don't think it's that. Otherwise, the only thing we can do... Oh, well, let's just break the link to that just to make sure we're only doing one path. It could be that there's another type of overlap that we're not checking for. I mean, that's possible. So the thing to think about here is that think through what could actually be kind of affecting this scenario. Could it be that there's some kind of collision system switch that's not allowing our actors to overlap? Maybe that's it. They clearly are colliding, that's for sure. So it's useful to sort of take a step back and just think about these things and see what's what the problem is. So one thing we can do is we can just check and see if there are any other events that maybe we should look at. We're looking for collision events, really, aren't we? So there's begin overlap on the actor. So there's an event hit. I wonder if that maybe is part of the problem. Maybe we're using the wrong type of hit event again. So let's try that one out. Let's see if we get any better results from here. If we use a different type of event. So let's just break the link on that one. And see if the hit event is actually the one we should be using. The other possibility, of course, is that we're okay, so we're getting a lot of hit events, and our zombies definitely want to eat the character, and the characters are definitely dying because they're being removed. But it seems like there's probably quite a big kind of radius of aggro, right? So things are probably hearing too much. We probably should localize that effect a little bit more. Okay, so we definitely wanted a hit in some way. Let's just see what message we've got. Okay, so if you get we were just getting a complaint that the other thing was kind of wrong, so maybe what we should do is we should have a check here. Yeah, just to make sure that we're doing our logic only if we've got a valid actor. That's probably a good plan for pretty much all of our blueprints. We should probably do this here as well, but we won't for now. So it seems like the hit event's good. Maybe one of the problems is that when we emit our noise from our student, we're doing it so that the noise is relatively big, or maybe we should do it so that our zombie, our sensing component on our zombie, has a smaller hearing threshold. So we probably want this to be a lot smaller, just so that we don't aggro all of the zombies onto the same on the first character that gets hit, essentially. So let's just see how that works. So one of the zombies gets hit, it draws all of the others, which isn't ideal, is it? I mean, they're certainly reacting, that's for sure. So go back to student again. Sorry, not student. Zombie. That's still probably quite a large radius. Maybe the other thing is we should sort of update our sensing interval for our zombies to be a little bit kind of dumber. So let's maybe make this 600. And maybe make this 600 as well, want our zombies a little bit more kind of... 600 is still 6 meters, which is quite a lot. What we want is we want the local zombies when a collision happens to become part of it, but not everybody. Okay, that seems reasonable. So this idea of the clustering zombies thing is about some of the zombies going into like the wait state and not walking again. So maybe what we should do is we should take our zombie behavior tree, which is over here, and maybe we don't kind of want that weight in there. Maybe we should take this weight down a little bit as well, just so that they're not sort of stood around too much. Let's see how that looks. So you can see that a lot of this is kind of tweaking on fairly basic behaviors, right? So in this video we've managed to make a zombie. It reacts to touches and it reacts to sounds, and it will attack an agent if it gets close to it. Obviously you can improve these things, so maybe you want to make the character look towards the thing it's attacking like we did in the guard video. But what you probably should think about is, how do we make zombies a little bit more kind of zombie-like, right? So a lot of it's going to be things like animation and movement speed. Maybe we should make our movement speed slower. Because these zombies are kind of moving around a little bit fast. But what else could you do to make the zombie a little bit more interesting? Maybe you should change the movement speed based on whether it's got a target or not. So what I'm saying is, a lot of this kind of thing is about how you want the character to feel like what you want the character to behave like. Maximum walk speed, let's go. Make them really slow. Or do I randomize the walk speed at some point? I can't remember whether I do. No, I don't. So let's just clean up this graph a little bit. We did get some of those other events occasionally, but in this case this one's the one to try. So we should have a sort of slightly slower set of zombies, which is kind of useful. Maybe we could up our RVO avoidance thing again. One thing we probably want to do is we definitely want the zombies, when they're aggroing something, to turn in the direction, face towards the thing they're aggroing. So I think we'll call it a day there. In the next video we're going to go back to the guard. One of my students has asked if we can do like a patrolling behavior for the guard, so we'll go back and do that one next, and then we'll come back and maybe make this zombie a little bit more interesting, or we'll maybe go on to the mob AI, because I know people want to see some of that stuff. So there you go. Simple zombie behavior. I would urge you to try and play around with these Mixamo characters, and they're kind of useful for prototyping, just because you can see there's a different character there. We should probably look at things like animation states for this type of character in the future. We'll probably do that on the mob, because the mob will have to do things like attacking from range and attacking in melee and those kind of things, so maybe we'll do something there. Maybe I'll even model the character for that one. So that's it for this video, and I shall see you again soon.